A couple of weeks ago, I made a video where we hacked this Apple IIc display. As you can see, it now has a white tube instead of being a fluorescent green display. I generally don't mind fluorescent green graphics, but on an all-white Apple IIc, this looks just right. Unfortunately, this display has two issues. The image is shaking slightly. It's not much, but it's enough to drive me crazy. And with this fault, the display isn't really usable. The second issue is that the image is way smaller than the display. In this video we are going to try to fix this weird issue and see if we can adjust the image despite the lack of adjustment knobs. If you want to pause this video and watch the tube swap video first, you will find the link below. So let's get inside and start fixing stuff. I have already made a full disassembly in the previous video, so I'm going to move quite quickly here. And the usual disclaimer applies. Please don't poke around inside CRT displays without proper training. They may contain high voltages even with the cord unplugged. By the way, the image was already shaky before I made a tube swap. I have tested the display with two other Apple IIs. And I have tested the Apple II with another display. I have also, since the previous video, tested the display with another original Apple RCA cable. A few viewers have also suggested that this may be caused by interference. So I went ahead and tested this Apple II in a different building. I have also cleaned all the pots and all the connectors. But so far, nothing has helped. In the previous video, we also replaced both RCA connectors, since they are known to go bad. But obviously that didn't help. And with this massive shield, it's not likely interference coming from the Apple II. These displays are very small, but they are extremely compact. Definitely not easy to work on. And to remember how to put it back together, I'm taking tons of pictures, because this display has so many connectors. Okay, the main PCB and the neckboard is out, and it's absolutely tiny. Let's start pulling some caps and see if they have dried up. Okay, so I did a quick inspection and I found a couple of suspects. So check out the board here. It has gone all black. I don't think the diodes are bad, because then the board would have stopped working entirely. However, this cap here may have been cooked from all the heat coming from these diodes. And possibly C702 here as well. So they definitely need to be checked. And then we have a second suspect here. This cap here is sitting very close to the tube, and it has gone all black. This could of course just be soot, but we definitely need to check it. So let's pull some caps off and see what values we get. Okay, let's start with the beefy C704. And by the way, if you are playing along here, you may want to know that there are at least two different manufacturers of these displays. And there are at least two revisions of this board. And my display here was made by Samsung. So if you are ordering caps, there's really no easy way. You just have to take it apart and check the values. And the two revisions I have seen of this board are very similar, but they have a slightly different set of caps. And between the two manufacturers, the display looks identical, but they are completely different inside. Well, there actually is something yellow underneath this cap. So that's definitely a suspect. Let's see if it comes off easily. And it does, so probably not glue from the factory. If it was glue, it would probably not come off this easily with just some IPA on a Q-tip. But it could of course be some flux residue. Let's pull this one off too before we check the values. And it's a 4.7 micro, 50 volts. And it's within specs. And the ESR is 950 milliohms. So this small cap is probably okay. And the large cap is a 2200 microfarad, 16 volts. And it's within specs too. And it's showing very low ESR. So according to my meters, these two caps are okay. Well, I did a full recap on my PC Junior display a few months ago, and the values were showing okay on both of my meters. But the flickering issues went away after the recap, so I'm not gonna trust my meters. And I'm gonna move on and replace all the caps. Yeah, the PC Junior display was behaving really weirdly. One of the corners had some flickering, but the rest of the display looked okay. And after the recap, it's very nice and stable. And I'm actually pretty impressed by that display. It has really vivid colors and a very sharp image. I'll probably use it for other systems too. It's really hard to find a fault like this, because the display mostly works. It just has that slightly shaking image. So presumably one of the components is slightly out of spec. Let's see what values we get from C107. The cap then has gone a bit black. I don't actually know if the tube gets hot from use. I've never felt compelled to touch it when the display is on. That's probably wise. Samiva. Never heard of this brand. So 47 micro 16 volts. And pay attention when you order caps for these boards. Because this bugger here is bipolar. And I presume we need to lay it flat to fit. Just like the original cap was. It looks a bit like an afterthought. Well, it looks really bodgy. But I don't think I can do much better. So I hope those resistors don't get too hot. I guess whoever designed this board didn't realize that there wasn't room enough for this cap. And then they had to lay it flat to make it fit. And I guess we better glue that Nichicon down like it originally was. Well, the board actually looks a bit wet now that I had a closer look. And whatever that stuff is, it comes off very easily. And I'm kind of hoping it's electrolyte, because I've been working on this project for quite a while. It would be really nice if this finally fixed it. And this looks to be a bipolar cap too. Yeah, really odd brand on these caps. And it's a 4 microfarad 25 volts. That is a pretty odd value. I wonder what I ordered. I better check. Well, I decided to check this cap. And despite it saying 4 microfarad on the cap, it's actually a regular 4.7. Well, not regular, it's a bipolar cap. But it's definitely not 4 micro, like it says on the cap. So that's a bit odd. And also, I wonder why it's so bloody huge. For a 4.7 micro at 25 volts, this cap is absolutely enormous. I had a look on Google, of course, but unfortunately I couldn't find a spec sheet. So too bad that Apple went with this odd brand. And the same thing with this cap here. It's really hard to tell if it's electrolyte or if it's old Flux. But it comes off very, very easily. Well, this is going pretty smoothly, but I thought I'd stop here and show you something. So this entire part of the board here is all damp. So if I take a dry Q-tip, this stuff comes just right off. I mean, this can't be old Flux, surely. At least I have never had old Flux come off that easily. So I guess it's cap juice. I can't be sure, of course. But what else could it be? And it seems to be mostly in the middle of the board here. So I think one of the caps here is leaking. But it's hard to tell which one, because this gunk is kind of spread out. But I'll continue here and see if I find something interesting. And there's one electrolytic cap on the neck board, so I guess this one is easy to miss. So don't forget it if you're ordering caps. Well, it's moving along quite nicely, and I'm cleaning that liquid off as I go. And I think I found something that we better take care of. That's a big splash of solder. I don't think it was shorting anything, because it got stuck under this resistor. And there's actually some more solder residue here. I don't think it's causing our problem. And I don't think it's my doing either. But we better clean it up. Well, so far it's been pretty easy. But the last one is of course going to give us some trouble. So there's a cap down here, inside this shield. So we're gonna have to remove that shield. I probably could replace it by using tweezers. However, there's plenty of that liquid on the board inside the shield too. So I think I'm gonna go ahead and remove that shield and clean the board. So let's see if my desoldering gun has enough power to remove that shield. And I think it does. At full speed at least. Removing a shield like this used to be a bit of a task. But now with the desoldering gun, it only takes seconds. And these legs are bent, so I need to get these tabs perfectly cleaned. Well, this tab actually broke off, but I think it's enough left so we can solder it back on. Now let's see if this comes off. And it does. And now we can access to clean the board and replace that cap. Alright, so all the caps are replaced. And whatever that liquid was, it has now been cleaned up. And now to the adjustments. And the main issue with this display is the width. The picture is way too small for that tube. So I checked in the manual. And according to the manual, it's L505. And it's this large coil here. And I think I have found the tool for it. This thing here says PK606A2. And it fits inside this coil. So I can twist and turn and make some adjustments. So I think the next step is to connect this board with the tube and see if I can access this coil while running the display. Well, I decided to check all the caps off camera not to bore you. And my meters don't reveal anything weird. But we have seen this before, so this doesn't really tell me much. There were about 25 caps in total. And the only thing that worries me is this huge cap that we don't have the spec sheet for. So let's try that display and see if this recap made any difference. Okay, time for a test. Let's turn the power on. Well, the power LED lights up. And we've got something on the screen. So I haven't killed it at least. But we do need to make some adjustments. And this isn't looking too good. So the image has changed quite a bit. Well, to begin with, it's not narrow anymore. And something smells badly. Yeah, something is wrong. Let me turn that on again. Yeah, something is getting hot. And something popped. So I guess I made a mistake. Well, let's take it apart and see what it is. And man, that is smelly. Wow, I found a problem. Check out C517 here. Why is it so happy? That Nichicon just blew out its guts. Look at the splatter all over the shield here. But it's not installed the wrong way around. So I guess I must have mixed up the caps. Let's pull the board out and have a look. Okay, let's find my mistake here. And I probably misread the numbers. And someone's gonna have to do some cleaning here. What a mess. And that's not a happy cap anymore. This cap is 1000 micro 16 volts. And C517 needs to be a 100 microfarad 63 volts. Well, no wonder it popped. That was a bit of a silly mistake, but it's an easy fix. However, I wonder if I mixed it up with another cap. So I better check if I put that cap somewhere else. And I found our cap. It's up here in the neck board. How the heck did I make this mistake? So up here in the neck board we should have a 63 volts 10 micro and not 100 micro. Now let's install it where it belongs. And I'm not gonna edit this out. Of course I make mistakes. And so do you. And it's a bit trickier to replace the cap with the board back in. But now C517 has the correct value. It's funny how mistakes tend to come in pairs. So let's put the correct cap on neck board. Okay, time for a test. Let's see if I got everything right this time. Well, the image is still washed out. Let's see if we can make some adjustments. Well, that looks much better. Well, it's a lot less shaky than before. But I have to say, it's not perfect. Let me move in a bit closer. Well, it's definitely much better. So perhaps I'm being a bit too picky now. So let's see if we can get it close enough to the edges. I know it maxed out before we reached the edges. So this is the widest we can go. Now let's adjust the height. Okay, let's get the image horizontally centered. Some of these spots are pretty hard to reach. And the centering adjustment isn't quite as easy as the other adjustments. To center the display, we have to break off the glue from these centering rings and then turn them. Okay, I marked a position in case I mess this up. Now let's see if we can get that old glue off. And it's actually not glue. I think this is silicone. Well, it comes off quite easily, but it's a bit hard to reach. Let's try to cut this stuff off. Yes, this is definitely not glue. Now these centering rings can move freely. So this ring is quite easy to adjust, but the inner ring has its tab all the way down here. But perhaps without the camera on top of the display, maybe I can reach it. And that made a huge difference. So I don't think we need to turn them quite that much. Let's see how off we are. And I think we still have a bit too much brightness. And yes, it has moved way to the left. So let's move it back a bit. And I don't have a high voltage glove, so I'm using a piece of plastic to push on the lever. Well, the inner ring seems to push the image to the left. Let's push on the outer ring and see what it does. And it moves the image upwards. So that's the one we need to adjust. And yeah, that's much better. Now let's push the image slightly more to the right with the inner ring. Yeah, that looks pretty good. Yeah, I think this is the best we will get. And the image is very nice and sharp. And I'm probably being slightly too picky. And I have a wide angle lens here, so you're not quite seeing what I'm seeing. But as the image gets closer to the edge, it starts to get distorted. So I'm not going to push this too far. In fact, I might make the image slightly narrower. Yeah, so hopefully you can see this on camera. But as I get closer to the edge, the image gets very distorted, especially on the right side. And the weird lines you see on screen, they are not here in real life. I can put the camera slightly out of focus to get rid of them, but then the image will look slightly out of focus, of course. But this is closer to what I see in real life here. Now to the final touch. As suggested by a viewer, now that this display has a white fluorescent tube, we can't have these green LEDs, can we? So let's pop them off and use white LEDs instead. Problem is, these are a bit weird, so I'm gonna have to modify at least one of these because it's slightly too high. So I'm just gonna sand the tip off and make that LED much shorter. Yeah, that should do the trick. Now I think it will fit. Well, it doesn't quite fit the through holes, but there is an extra hole in between. So if we use that hole and then bend this leg it will make contact with the pad. So we can solder it to the pad, like so, and snip those legs off. And with the legs bent like this, we can put this LED in at a slight angle, like so. And I'm obviously not going to throw away those original LEDs. I'll put them in the bag and throw them inside the display, because this display is obviously going to go back to original sometime in the future. And the voltage drop across these modern LEDs is completely off compared to the original LEDs. So I'm gonna remove one of the wires and put a resistor here. I did the math and it should be a 75 ohm resistor, but these modern LEDs are so damn bright. I think we better at least double that. So let's try with 150 ohms. And now we only need to attach the wire to the resistor, like so. We don't want any shorts, so let's get a shrink tube on. And some heats. Okay, so if we turn the power on, let's see if it works. And it does. Perhaps a bit too bright. Although it probably looks much brighter on camera than in real life. But let's give this a try. Okay, not the easiest thing to get on camera, but I think it worked out quite well. So let's put this display back into one piece. By the way, if you like this type of content, let me know with a thumbs up. Well, there you have it. Mystery House in glorious phosphor white. I can't really think of any more ways of molesting this Apple IIc, but if you have any interesting ideas, please share down below. We can always take things too far. The white LED is slightly too bright, so I'm gonna try with a different resistor. And now is a good time to watch part 1 if you haven't seen it yet. I would like to end this video by saying thank you to my patrons. You guys are the best. Thank you for helping me out making more videos like this one. And if you want to become an early supporter too, check out the link down below.
Thank you for watching. I'll see you soon in the next video.